Today we will look at farm data language and how it can help you gather and structure data from your database systems. So first I want to go into what farm data language is, and it's a language to query across all database platforms and instances and take this data back and create advanced reports and dashboards. And it also allows you to expand the language itself and what you can query on to fit better with your organization. So farm data language and this presentation have two key concepts that I will look into. FDL, farm data language, that brings data warehouse capabilities to the DBA, and properties that create data points for FDL, typically based on SQL queries. If you know anything about the database instances you have, you need to query the databases. And for this use case, I have 4 database instances: Manda, Silos, Cecid, and Tatooine. They're all SQL Server database instances. And 4 is not that many database instances to manage. What I want to know today is how many user sessions are connected to each database instance. And to do that, I need to run a SQL query. I have a query I want to run that counts up the number of user sessions they have. It's highlighted here in orange, and it's my favorite SQL Server counting sessions query, but not counting the background sessions and not counting the task manager query. So I run this query on each database instance, and then the results of this query has to be copied from my SQL query output and pasted into an Excel spreadsheet or something like that for analysis. And you will end up with something like this. And I think this is something that most DBAs do regularly. They take some data, query, take it back, put it into some sort of report or Excel spreadsheet or things like that. And when you don't have to do this all the time and you just have 2 instances, this is easy to manage, but it's boring, it is repetitive, and there is a lot of manual steps involved here. And if you sometimes you'll have other database platforms you need to gather data from as well, like if you have an Oracle instance that you have in your environment. So I have a Tanab here, which is an Oracle instance, and the query that I use for SQL Server is not, of course, compatible with the other database platform. And you can have the same issue if you have different versions of the same database platform. So if you have SQL servers, you can have difference on your query between SQL servers on-premise, some types of database in Azure, or it can be very old SQL servers and very new SQL servers. There can be differences in the queries. And I think it's a reality in many places, often when I work as a DBA in the past, that I got responsibility for not only the database platforms I know pretty well, such as SQL Server or Oracle, but also other database platforms that I hardly knew at the time, like MySQL or Postgres. Then you are left with a lot of different database platforms you need to report on and you need to gather data from. And what you end up here with is multiple queries you have to run, one on some instances and others on the rest. And you also need to track what query should be run on which instance. In this case, I only have SQL Server and Oracle, and there is still just 2 different queries. But they do the exact same thing. They gather, they count the users, but not background sessions from the database instance. And if you want to look at multiple metrics, you will see that you'll have 1 query for each database platform for each metrics. So you'll have 2 different queries for instance name. You'll have 2 different queries for session count that we looked at earlier. You'll have 2 different queries for disk usage. And you'll have 2 different queries for memory usage. And so only when I look at these simple metrics like instance name, session count, disk usage, memory usage, and we only have 2 platforms, we end up with 8 queries we need to maintain. understand, and use to query the data that we need. And we need to pick the right one to run on the instance. So we need to know the instances we manage quite well already. And this can be a problem in itself, as we'll look into later. I think most DBAs, they end up with a long list of SQL statements that are used to gather different bits of information from the databases they manage, like a long list of really good queries. And when you get bored of the manual job of running this query and copy and pasting the results, you start looking for ways to avoid this manual labor. So maybe you want to make them into a view or join them together, so at least you don't have to run all the different queries independently. And you'll end up with something like this. This is the same 4 metrics for each database platform joined together. It looks more stitched together, but has a large drawback as well. As a DBA, you will likely end up with many of these nice to have, but very complicated queries. And I've spent many hours looking for the comma that was missing, or the single quote turned into a backtick, or the parentheses that went missing. And also, if you want to turn this into a script, you'll get something inflexible, something that needs a lot of maintenance. And when somebody asks you to gather a new metric to add into this, you have to dive into this old code with a lot of complex queries to sort out. So when we find a good query, wouldn't it be nice if we could use an alias for each of these queries? So when we need the result of that query, we can just ask for the alias instead of having to merge or join difficult queries together. So we give the name of the instance query, the alias name, the query behind the session count, the alias total session count, the query for disk usage, the alias disk underscore usage, and the memory usage query, the alias memory underscore usage. And this way, at least when we have found the right query, it will stay right. And if we need to correct it, it's a simple query that it can be easily understood. So imagine just running this simple query on each database instance, just querying the different aliases and having the aliases automatically resolve for the different queries for the different platforms and versions. That is the idea behind FDL. So if you have a large database environment like a managed service provider or a large enterprise, there will always be a mix of versions and platforms that will change over time. So there is a natural way of structuring these aliases together, because some concepts like memory usage and total session count have a single value which is associated with that instance. And other concepts like agent job details, where each element of the list has a set of properties, this can result in a structure similar to a directory structure used to organize files on disk, or a tree-like structure of an XML document. Each of the nodes is a result of an individual SQL query, so that the case of total session count, there is the same SQL query I used manually on the 4 instances, but when this is defined as a node in this FDL structure, instead of running it manually on each database instance, it's queryable as the value of a property in the FDL tree structure. So we define this in an XML as a property, which has a key and a value, and the key here is total session count, and the value is the result of the SQL statement. To limit the query to run only on database types that this query work on, we add also a compatibility tag. And in itself, it's a query on a different property, in this case, the database type. And this allows a given property key to have multiple definitions, so that each database type might have their own SQL query, or different versions will have different queries. So know the problem that we had earlier, where we needed to remember to run the right queries on the right database platforms and versions is taken care of. And this is a very important part of how this can function on multiple database platforms and versions. Compatibility allows for multiple queries to gather the same type of data from multiple sources. Any property can be a compatibility tag in another property. So you can make another property definition later based on the number in total session count. For instance, if you want to have a property that will only run on database instances with more than 100 sessions connected, for instance. Then we have the value definition, and this is where we give the property key, total session count, its value. And we define the engine it will run on, and in this case, it's a SQL statement, just like the one we run manually earlier on. And the last parameter, valid for, which is a cache hint, and this is how long this value is valid for before we should run the SQL query again to get fresh data. And in this example, it's set to 1 minute, since the information about how many users are connected changes quite rapidly. But for other queries that are heavy or doesn't change that often, maybe a valid for 24 hours is the correct setting. And this is an important parameter to offload the database instances when you have data that needs to be queried quite frequently. And it also allows for a more rapid response from the system. If you have more advanced queries, you can create properties with sub-properties. Examples here from the table space information on Oracle, where you'll have the table space name as the top value, and sub-properties like the type of table space, the size of the table space, etc., as sub-properties of the primary property. It's called nested property. And this is something that will go more into detail when we have other videos where we look into creating properties ourselves to expand the language to make sure that we get specific information that we're interested in our environment. So you can have here either queries that respond with one value, or queries that gather a lot of data and create nested sets of properties. So in this FDL structure, we can query similar to a directory path. And it's a bit like directories and files. If you want to get a value, we type the path and the value is returned to us. And we can start off with a simple query. We ask for the name of the instance. And this is a simple query in FDL. Just as when we did this individual SQL query and put it into Excel. It's the same kind of query. But we just write instance, which is the starting point of data that is collected about the database instance. And we write /name, and then we get the value for the property name for each instance. And it will show up like this, a list of database instances that have the property name defined. In the background here, there is SQL statements running on each database instance, gathering the data, caching the data, so that we can query it again in the near future. If you want to add column formatting, we can add it with the squirrely brackets and put in database instance in the double quotations here. This is similar to what we do in SQL statements, where we want to give column headers a better name. We have a new concept here called anchoring. And anchoring is a reference pointer that allows us to join two properties together. So here we anchor the instance node into the I variable. So this variable could be any text. But this allows us to join data that is connected to the same instance again. So when we want to query a different subnode to instance, we are sure to have it joined on the same instance that we did the instance/name query. So the next step here is to add a new column to the query. So we use the $i sign to refer to the same instance element again, and then we query for the new column, total session count, and we format it as session count. And now we have joined two properties that are not connected in any other way than there are properties on the same database instance. If we didn't use this way to connect two properties, we will get two columns that are not connected and could have data from multiple instances. So it's important to connect them together using the same anchor. And since we use an anchor, we open the possibility to query multiple values at once, starting from the same node item. For instance, if we want disk usage value displayed alongside the database instance name and session count, and this allows us to put together information from many different queries into one result set. Now we've added disk usage alongside the query, and we get the view that contains multiple key metrics for that database instance. And now we have something that can solve our initial problems of querying and merging data from multiple database instances using different aliases. It is in fact a bit like how a data warehouse works, with multiple queries extracting data and transforming them to connect together and allow us to query on top of that data. But in FDL and with the caching engine, it's done on the fly and in real time, and it's very easy to write. We will follow up this presentation with other presentations, allowing you to create your own property definitions, write more advanced FDL queries, and really dive into this, because this can be used again in dashboards, in reports, and in gathering really great overview of your database environment, and be really beneficial on how to understand your systems and the databases that you work with. So thank you very much, and I'll see you again in a later presentation. DBWatch Control Center, redefining database operations. Please visit us at Facebook, Twitter, LinkedIn, or YouTube.